A man named Martin Molen is creating a music machine, and he cut gears out of plywood. To make them more decorative, he cut along the spokes of the gear to the depth of the first layer of plywood in order to expose the glue layer, thereby creating gears with some color and texture. This video shows how you can do that type of decorative cutting with MillWrite. On the drawing screen is the gear and spokes that I created in the previous video. To make this gear more similar to Martin's gears, I will change the spokes to 5 wedges, and I'll alter a few other parameters. Although I will leave the spokes with a taper because I think that looks better, and it might create a stronger gear also. I will also make a change to the gear that you might want when cutting a gear out of soft materials like wood. I'll zoom in on the teeth and then change the base of teeth from 1 arc to 3 arcs. As you can see, as I switch this option back and forth, switching to 3 arcs leaves more material around the teeth. Now to create a decorative cut inside the spokes. The easiest way to do this is to make an offset of the spokes. To do that, I can click the Edit button at the top of the drawing page and select the Offset function. At the right edge of the menu is the letter O, which shows that the letter O is the hotkey for that function. Therefore, I could have pressed the letter O on the keyboard to bring up the Offset function. The top of the screen changes and offers the option of offsetting entire polylines or individual links within polylines. I want to offset the entire polyline, and I want the cam type of offset. I do not need to worry about deleting crossovers or turning on the smoothing option because these are precise drawings as opposed to the sloppy geometry that we get when we do those raster to vector conversions in which an image is converted into geometry. I will put the offset on a different layer, and I'll give the layer a name such as offset of spokes. I will create the offset by dragging it rather than by value because I don't know the value I want for the offset. So I click the spokes and then move the mouse, and you can see that it is dragging an offset. I can zoom in or out with the scroll wheel while I am doing this. As I drag the offset, the value is displayed at the top of the screen. If I decide I want a specific value, I can do it while I'm dragging the offset simply by typing the value. For example, if I decide I would like the offset to be 0.4 inches, then I type 0.4. As soon as I press the decimal point key, a window pops up to ask me for the offset value, and then I can press the 4 key and then the Enter key. Then the offset is created at exactly 0.4 inches. In order to make the tool cut in this area, we need to create a boundary to tell the tool where it must stop cutting. I will create a circle to specify the outer boundary. I want the circle on the same layer as the offset, so I'll set the active layer to the offset of spokes. Then I click the right mouse button while the mouse is not hovering over anything, which brings up the drawing menu, and I'll pick the option to draw a circle. Then I click the center of the spokes and drag a circle out to where I want the tool to stop cutting. This looks okay. Now I will create a smaller circle to stop the tool from cutting all the way to the center. So I click the center of the spokes again, but this time I make the circle stop about here. The spokes and the gear are on layer 0, so I will turn that layer off temporarily to help you understand what I'm doing. I want the tool to cut within this area, but not inside these 5 wedges. To do that, these 5 wedges need to be set as an island so that the tool avoids them. The center circle also needs to be an island so that the tool avoids cutting into it. The outer circle needs to be set as a pocket. So I will let the mouse hover over the outer circle and then set the cam operation to pocket. I will select the same 1/4" tool that I chose to cut the spokes and gear. However, the depth will only be as deep as the first layer in a sheet of plywood, which I will assume is 0.06 of an inch. I want the CNC machine to cut this pocket before it cuts the shaft hole, wedges, and gear, so it needs to have a machining batch with a lower number than the other items. Since the shaft hole is set to a machining batch of 10, I will set this to a machining batch of 5. Now I need to set the circle and wedges to islands. In the previous video, I showed that you can switch from one item to another by moving the mouse back into the drawing, clicking one time, and letting the mouse hover over the other item, and then sliding the mouse back over to the right side of the screen. Going back and forth like this is a bit of a nuisance, however. There is an easier way to switch from one item to the next. I will go back to this outer circle. Then I press and hold down a Shift key on the keyboard, and a menu appears on the bottom of the screen to remind me that while I am holding down the Shift key, if I use the mouse scroll wheel or the page up or page down keys, I will jump to one of the other items that is visible in the drawing. So I turn the mouse scroll wheel and the outer circle becomes unselected and the spokes have been selected. I can now set this to be an island, and I give it a machining batch of 5 because it has to match the batch of the pocket so that MillWrite knows that the pocket and island belong together. I could now press the Shift key down again and use the mouse scroll wheel to jump to the inner circle, and then set that to be an island and give it a machining batch of 5. But another method of giving items the same machining parameters is to use the Copy Cam Settings function. I could set one of these user-defined buttons to Copy Cam Settings, or I could click the Select from All Commands button, and the first option in the list is to copy cam settings to others. So I pick that function. I make sure the machining batch option is checked at the top. The message at the top of the screen reminds me to select the item that has the cam settings I want to copy. So I move the mouse over the spokes, and along the right side of the screen I can see that it has been set as an island and machining batch 5. So I click the left button to let MillWrite know I want to copy those settings. The message at the top of the screen changes to tell me to click the items I want to have the same settings, or draw a box around them if I want to set a bunch of them. So I click the circle, and now it has been set as an island and machining batch 5. Cutting this gear out of a piece of wood and cutting 5 wedges into it is going to create a total of 7 independent pieces of wood, which must be held down on the table. One option is to drill holes through each of the 5 wedges and through the gear, and then bolt the sheet of wood to the CNC table. However, there is another method, and that is to place holding tabs on the pieces to hold them together. When the CNC program has finished cutting, all 6 pieces will be cut out, except that there will be some small tabs of material holding the pieces together. You'll have to cut those by hand to release the pieces. The tabs will cause the tool to rise up in the Z-axis for a short distance, move over in the X and Y a short distance, and then drop back down, thereby leaving a small piece of material to hold the pieces together. To put these holding tabs on the part, click the right mouse button when it is not hovering over anything in the drawing, and the menu will appear. Select the option to Create Holding Tabs. Then click the location on the wedges where you want a tab to be. Wedges that are this large might need 2 tabs. I will also put a tab at the center of the hole, and I'll add 3 tabs to the gear. The size of the tabs are specified at the setup page under the CNC tab. Here is where you set the default length in X and Y and the default height in the Z axis. At the drawing page, you can override the height and length of the tabs if you discover that a particular tab needs to be stronger or that it can be reduced in size. After the tabs have been created, you are ready to look at the 3D view of the toolpath. You can see the tabs if you zoom in. You can switch to the 3D model to get an idea of what the tool is going to create. The reddish color shows where the tool has reached its deepest level, and the tabs will show up as small dark areas because they are above the deepest level. You can flip the 3D model upside down to get a different view of the tabs. You can also flip the model upside down by clicking the top button with the right mouse instead of the left mouse. If you let the mouse hover over the top button for a second or so, the help message will remind you of that. If everything looks okay, switch to the NC program page, and there is your CNC program. It is ready to send to your CNC machine.